Hello students, hello pre-calculus and honors algebra 2 students. We are all starting our last unit of the year and it happens to be the same unit for all of you. So you're all going to take the same notes, and for pre-calculus it's notes number 51 and for honors algebra 2 it's notes number 56. We're starting a unit that's called conic sections, but we start with a review of topics you've seen before, distance formula and midpoint formula. So while you're getting yourselves ready to take some notes, I was thinking about how so many of you have been mentioning that you're catching up on a lot of reading or just doing a lot of reading. And boy, I wish I had checked out some library books before the library closed, because I feel a bit kind of deficient in books, but it got me to wondering about this. Maybe you can think about this for me. If a mathematician wrote a fantasy novel, would the pages have imaginary numbers? Oh wow, with so many of you listening in today, I heard a lot more laughter than normal. That was fun. Okay, so let's talk about the distance formula. We're talking about finding the distance between 2 points, and we'll call the points x1, y1, and x2, y2. By the way, I have a new device, and I'm playing around with different kinds of ink right now. This is calligraphy ink. Tell me what you think. Also, I'm getting used to it. I have a different stylus, and I notice it's doing a lot of clicking. And so hopefully as I get better with this, the clicking will subside, but I'm also interested in your opinion. I will write some of this lesson with my new stylus, and then I will write some of this lesson with my old stylus, and you can tell me what you think is better, because I think with the new stylus, I can do better handwriting, but there's more clicking. And with the old stylus, I don't have any clicking, but my handwriting is worse. So you'll have to weigh in on that. Tell me what you think. Okay, let's get back to the distance formula. So let's say we're finding the distance between the points x1, y1 and x2, y2. We can visualize this. Let's say we have x1, y1 over here and x2, y2 over here. Really all we're doing is a form of the Pythagorean Theorem. So let me label my points. Oops, that's a 1, x1, y1, x2, y2. So if you were to make this into the hypotenuse of a right triangle, here's your right triangle, then the length of one leg would be the difference between the x-coordinates, so x sub 2 minus x sub 1, and the length of the other leg would be the difference between the y-coordinates, y sub 2 minus y sub 1. And so then the distance, which I'll call d, the distance squared equals one leg squared plus the other leg squared, according to the Pythagorean theorem. So then if you were to just square root that, you would have the distance. And so the distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we use that as our distance formula. Okay, now for the midpoint formula, also the midpoint between points x sub 1, y sub 1, and x sub 2, y sub 2. I like how that calligraphy pen makes my x's look. What do you think? Okay, so let's go back to the drawing I made above, and if I wanted to find the midpoint, it would be roughly here. So what you would do is find what's halfway between the x values, and you would find what's halfway between the y values, and we refer to that as the average. And so the midpoint between the 2 points is going to be the average of the x's, which is x sub 1 plus x sub 2 over 2, comma, the average of the y's, y sub 1 plus y sub 2 over 2. So that's our midpoint formula. So we're going to go ahead and do a few examples now. Okay, let's say we have the points 3, -3, and -1, 5. Let's find the distance between the points, and let's find the midpoint. And it doesn't say anything about having to graph, but I just thought it would be fun to graph, just to give us a visual of what's going on. So we have 3, -3, and we have -1, 5. So we're looking for the distance between those 2 points, and we're also looking for the midpoint, which we could sort of roughly estimate at this moment. Okay, so for the distance, we have the square root of the change in x, -1 minus 3, quantity squared, plus the change in y, 5 minus -3, quantity squared. And you know it doesn't matter what order you subtract the x's in. It can be -1 minus 3 or 3 minus -1. Same thing with the y's, because if you're about to square that difference, then it won't make a difference. It won't make a difference when you square the difference. Okay, let's simplify. So we have -4 squared plus 8 squared, and that gives us 16, the square root of 16 plus 64, and that gives us the square root of 80. And so let's go ahead and simplify that. We're going to leave it as an exact answer, so don't get a decimal approximation, but just pull out your perfect square. So this works out to be, I believe, 4 square root 5, because you have the 16 times 5 in there. So there's the distance between the 2 points. And now let's go ahead and find the midpoint as well. Okay, so the midpoint, we're going to add the x-coordinates and divide by 2. So 3 plus -1 divided by 2. And then we're going to add the y-coordinates and divide by 2. -3 plus 5 divided by 2. And so that gives us 2 over 2 and 2 over 2. So that gives us the point 1, 1. Now, look back at the graph. Does it look like the midpoint was at about 1, 1? That seems pretty logical. How are we doing with the tapping noise? I want your feedback. What do you think? Now for the next problem, I'm going to switch to my regular stylus and we can see what we think of that. Problem number 2. A triangle has vertices -1, 3, 5, 2, and 3, 6. Classify the triangle as scalene, isosceles, or equilateral. So if the sides are all different lengths, it's scalene. If it has 2 sides the same length, it's isosceles, and if it has all 3 sides the same length, it's equilateral. So I'm going to name these vertices A, B, and C. And so I'm going to find the distance from A to B. So using that distance formula again, we have the square root of the difference in the x's, 5 minus -1 squared, plus the difference in the y's, 2 minus 3 squared. I'm going to switch to a regular pen. I don't like that very much. Okay, now that's going to be 6 squared plus -1 squared. And that's going to be square root of 36 plus 1. And so that's square root 37. Okay, that's one side length. And let's go ahead and find another side length. So let's find the distance from, how about A to C? So let's see, point A. So the difference in the x values would be 3 minus -1 squared, and the difference in the y values, 6 minus 3. We're going to square that. Okay? So this gives us the square root of 4 squared plus 3 squared, and that is the square root of 16 plus 9, and that is the square root of 25. Oops. And that is 5. So at this point, we know that it's not equilateral because we have 2 sides of different lengths. We haven't found the third yet. I'm going to go ahead and make some room here for the third side length. Okay, so the distance from B to C. So we have 6 minus 2 quantity squared plus 3 minus 5 quantity squared, and that would be the square root of 4 squared plus -2 squared, and that would be the square root of 16 plus 4, and that would be the square root of 20. And we could simplify that, but that's not the point. The point is this triangle scalene, isosceles, or equilateral? and all three sides are different lengths, so we would say that the triangle is scalene. Okay, now I was going to graph it just as a kind of way to verify the answer, so I could plot the points. So we have -1, 3. We have 5, 2. And we have 3, 6. When you look at that, does it look to you like all the sides are different lengths? I would say that seems reasonable. Okay, let's take a look at example number 3. I'm going to go back to my clicky stylus. My new one. Write an equation for the perpendicular bisector of the line segment joining the points -3, 4, and 5, 6. We're going to start by visualizing this. So we have a line segment, and we know its endpoints, -3, 4, and 5, 6. So there's our segment. I'm going to give those points coordinate or names A and B. So here's our goal. Our goal is to find the equation of the line that is the perpendicular bisector. So because it's the bisector, it goes through the center, and because it's perpendicular, it forms a 90-degree angle. So roughly this line, we're trying to find the equation of that line. So we need to know the midpoint of the segment in order to find that point of intersection. So let's find the midpoint of the segment, add the x values together, and divide by 2, and add the y values together, and divide by 2, and we get 2 over 2, so 1, and then 10 over 2, so 5, 1, 5. Now, looking at the picture, does that seem reasonable that that might have been at 1, 5 if I had done a better job of drawing my line? I think that seems reasonable. Okay, now remember that perpendicular lines have opposite reciprocal slopes. So, what's the slope of the line segment? The slope of segment AB would be the change in y, 6 minus 4, over the change in x, 5 minus -3, and that would be 2/8 or 1/4. So then what's the perpendicular slope? The opposite reciprocal of 1/4 is -4. So what we're going to do now is we're going to take the point that we just got, the midpoint, and the slope that we just got for the perpendicular line and put those together into the equation of our line. So the line that we're looking for, let's go ahead and write y equals mx plus b, and then substitute 5 in for y, and -4 in for the slope, and 1 in for x, and solve for b. So we have 5 equals -4 plus b, add 4 to both sides, and b is 9. So putting all of that together, we have the equation of the perpendicular bisector, y equals -4x plus 9. Now looking back at the graph, does it seem reasonable that that line, if I had done a better job of drawing it, might have a y-intercept of 9? Y-intercept of 9 and goes through the point 1, 5. That seems like it could very well be the perpendicular bisector. So that is a good check. Okay, so your assignment today is to do the worksheet, distance formula and midpoint formula worksheet. And I have included answers with the worksheet, and I've also included worked out solutions. I didn't make a worked out solution video. I just wrote out all the steps because probably with this particular assignment, not as many people would need a video. But if you do have questions or if you do need to see something worked out in the video form, please let me know. Thanks, everybody.